Hello everyone, good evening. I'm audible, right? Yes. So this is lecture number 11 of analytical geometry. So far, we have completed direction, cosine, direction ratio, um, and then planes, and then straight lines, right? So if you haven't watched all the previous videos, so go through all the previous videos and come back to this video. And the Telegram group, I have given you the question bank for DC, DR, planes, and straight lines. So practice all the problems. So in this class, we're going to start spheres, right? This class we're going to start spheres. So first, what I'm going to do is we are going to derive the equation of the sphere in central form and equation of sphere in general form. So there are two equations of sphere. One is central form, other is general form. For straight line, we have two, right? One is symmetric form, other is general form. For a sphere also, we're going to derive this equation of sphere in central form and in general form, right? So everything is about this ball only for the next 3 to 4 classes. Okay, because I cannot draw this 3D diagram in 2D. That is why only I am with the ball in today class. So everything I'm going to explain with this ball only. Okay, I just stole this ball from the neighbor house who is doing LKG UKG now. Okay, so we'll start. Okay, so first what I'm going to do is first we will define what is meant by a sphere. See, if you know circle, then sphere is very simple, right? It is extension, that's it. So everything you imagine with circle and extend to 3D. In 2D it is circle, in 3D it is sphere, right? In 2D it is circle, in 3D it is sphere. So first, whatever problem you have in a sphere, you just visualize that it's circle because circle is something that we can easily visualize because it is 2D, right? Okay. So first, what we'll do is we will define what is meant by a sphere, what is meant by a sphere, and then we will derive the equations, and then we're going to do some 10 problems today, 10 to 12 problems today in this class, right? Okay. So first, we will define sphere. Sphere, P-H-E-R-E. See, what is circle? Circle is a locus of all those points such that from fixed point to any point on the circle, the distance is same, right? You know the definition of circle. Same it is for sphere only. A sphere is a locus. A sphere is the locus of a point. Locus of a point. A sphere is a locus of a point which moves, which moves, which moves such that which moves such that its distance such that its distance from a fixed point from a fixed point from a fixed point always remains constant. Always remains constant. Yes, sphere is very easy, right? Sphere is very easy. From now on, everything will be easy. The first three topics will be slightly vague. That is DC, DR, plane, straight line. That will be slightly vague. But from now on, it is very easy. Spheres, cone, cylinder, conicoid, paraboloid. Syllabus will be completed, right? Okay. So very simple. So first, what I will do is I'm going to explain this with the help of circle only because it is hard to draw 3D here in 2D surface. So see, very simple. We have a fixed point, right? We have a fixed point, right? Let us say fixed point is C. This fixed point is called center. Let us have some fixed distance R, right? So we have a fixed point and we have a fixed distance R. R is a distance. Now you need to collect all those points such that whatever point you take on this boundary, the distance from that point to the center is same as R. This is a definition of circle Also same for sphere also, right? So we have a fixed point. Okay. So we have a fixed point and we have a fixed distance r, right? So whatever point you take, so this is the locus, right? Locus means set of all points that satisfy some condition, right? So these are the set of all points, right? This sphere, right? That means whatever point you take, right? Whatever point you take, the distance from this point to center is same as r. So you need to collect all those points, right? A sphere is a locus of a point which moves. So you can see all these are locus which moves such that whatever point you take, the distance from fixed point is called center, to that point always remains constant. See, it is just extension of circle. It is nothing but the extension of circle, right? So just visualize in 3D. So inside this we have a center. So whatever point I take, the distance from that point to center is always same. That is called sphere, right? Okay. So let us say the center is A comma B comma C, because it is in sphere, right? So we are looking at 3D surface, not 2D. If it is 2D means we will have only two coordinate. That is, we have only x comma y as center. But here it is 3D, so center, let's call it as A comma B comma C, and R be the radius, right? Then the equation is given by equation of sphere, equation of sphere in central form, right? Equation of sphere in central form is given by x minus a whole square, y minus b whole square, z minus c whole square is equal to r square. This is the equation of sphere in this is the equation of sphere in central form, right? X minus a whole square plus y minus b whole square plus z minus c whole square. You can easily derive this equation with the help of complex analysis. I'm not going to do this, right? So how we got this equation is very simple. You can easily derive with the help of complex analysis, right? Let us call this point to be z. Call this point to be z naught. Modulus of z minus z naught will be equal to r by definition of circle. Now you replace z by x comma y comma z. Z naught by something, you will have this equation. I'm not going to explain how this comes, right? Very simple. All these x comma y comma z, so this is some arbitrary point x comma y comma z. So whatever point you take on the boundary, that will satisfy this condition: x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. This is the equation of sphere in central form, right? Now, where a comma b comma c is the center and r is the radius, right? Where a comma b comma c is center, center, and r is the radius. And r is the radius, right? So, do we want me to prove this equation? So we can prove this by complex analysis, but I'm not going to do this, right? I'll just give you a hint. Let us call this point to be z. Call this point to be z naught. Then we will have modulus of z minus z naught is equal to r, right? This is the condition, right? Whatever point you take, the distance from z to the fixed point is always r, right? Now you replace z by let us call z naught to be center, z be any arbitrary point, so z minus z naught will be r. Now you replace z by xi plus yj plus zk, and you replace z naught by a comma b comma c. Then after distance formula, you will have square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square is equal to r. Now squaring on both sides, you will get this equation, right? Don't make it too complex. Let us uh, memorize this equation. Equation of circle in sorry, equation of sphere. See, this equation of sphere, right? Not circle. So equation of sphere in central form is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square, right? Where a comma b comma c is center and r is the radius. If center is origin, if center if center is origin, right? If center lies in origin, then you will have a comma b comma c to be 0 0 0. A comma b comma c is any point that can be center. If center is origin means, then you will have A to be 0, B to be 0, C to be 0, then you will have x square plus y square plus z square is equal to r square is the equation of circle if center lies in origin and if center is origin, right? So if center is origin, x square plus y square plus z square is equal to r square is the equation of sphere, right? But you always have to remember this equation in central form. Now we are going to derive the equation of sphere in general form, right? In general form. See, only 2 slides I am going to explain. Then we're going to do 10 to 12 problems based on this. YouTube is not receiving enough streaming as well. My video is clear. Is it lagging? Just a minute. I think there is some problem with my internet connection. Just a minute. Just a minute. I'm not receiving internet connection properly. Okay. So this is the equation of sphere in central form, right? X minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. Now equation of sphere in general form. So from the central form, I'm going to find the equation of sphere in general form. So, so what is the equation of sphere in general form? Sorry, in central form, it is x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square, right? Where a comma b comma c is the center and r is the radius. Okay. Now let us expand this, right? So we will have x square plus a square minus 2ax. So I'm just expanding in a minus b whole square formula. So y square plus b square minus 2 times yb plus z square plus c square minus 2cz is equal to r square, right? Is equal to r square. So let us collect x square plus y square plus z square. I'm just reordering minus 2ax minus 2yb minus 2cz, right? And we have a square, b square, c square. All these are constant terms. A square plus c, b square plus c square minus r square is equal to 0. Just grouping the terms, that's it. Okay. Now I'm going to make some substitutions now. So let's see, since this is r to c, I'm just going to use some substitutions now. So let us call this as x square plus y square plus z square. So instead of this, I'm going to put 2ux 2vy plus 2wz plus d is equal to 0, right? So instead of this, I'm just writing this 2ux plus 2vy plus 2wz plus d is equal to 0, right? Instead of this, I'm just writing this. What is 2u? So just compare this. I'm just replacing minus 2a by 2u minus 2b by 2v minus 2c by 2w, and I'm replacing this entire term to be d, right? So you just compare this. So you will have 2u is equal to minus 2a, 2v is equal to minus 2b, 2w is equal to minus 2c, and I have replaced d by a square plus b square plus c square minus r square, right? So this is the equation of sphere in see, whenever I say circle, you just replace by sphere, right? Without knowing, I'm telling circle sometimes. This sphere, right? Okay. So x square plus y square plus z square. This is the equation of sphere in general form. But we know ABC is the center, R is the radius, right? So that means, but here we have in terms of UVW. So let us try to find ABC in terms of UVW. So we have A to be equal to minus U, B to be equal to minus V, C to be equal to minus W, and you just bring this R square to this side. So you will have A square plus B square plus C square minus D. So the radius is root of a square plus b square plus c square minus d, right? So therefore this is the equation of circle in general form. What is the center? This center is a comma b comma c, but here we are writing in terms of UVW. So we know a is minus w, b is minus b, minus u, a is minus u, right? So minus u minus v minus w is the equation of, sorry, is the coordinate of center of the sphere. And what is the radius? Radius r is square root of u square plus v square plus w square, sorry, okay, we need in terms of UVW, right? Okay, so we will replace that because we know a is u. See, here we have in terms of ABC, but we will write everything in terms of UVW because here everything in terms of UVW, right? This is same as R is equal to square root of, so A square will be minus of U square. So we will have U square plus V square plus W square minus D, right? So U square plus V square plus W square minus D. That's it, right? So based on this two slide, we're going to do 10 to 12 problems now. Very easy. Equation of circle in general form is x square. This is called general form, right? This is the equation of circle in general form. So it is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Center is minus u minus vw. Radius is root of u square plus v square plus w square minus d. Right? So that's it. We will do some problems based on this. To find the equation of sphere, find the equation of sphere, find the equation of sphere which passes through 0 comma 0 comma 0 and which as its center, which as its center 1 by 2 comma 1 by 2 comma 0, right? Okay, so x square, equation of circle, it passes through 0 comma 0 comma 0 and as its center this, right? Okay, very simple. So let the equation of circle be let the equation of sphere. Let the equation of sphere be x minus a whole square plus y minus b whole square plus z minus c whole square is equal to r square. You can assume equation of sphere in central form or in general form also. You can assume in any form. I'm assuming in central form. Now it has its center 1 by 2, 1 by 2, 0. That is, this is the center AB 0. Therefore, we will have x minus 1 by 2 whole square, y minus 1 by 2 whole square, z minus 0 whole square is equal to r square. Right? This is the equation of sphere, but we don't know what is r. Now it is given, this is the required equation, right? This is a required equation. Now it passes through origin. So it passes through 0, comma 0, comma 0. That means this x comma y comma z, if I substitute here, this will satisfy this equation. So we will have 0 minus 1 by 2 whole square minus 1 by 2 whole square plus 0 square is equal to r square. So we will have 1 by 4 plus 1 by 4 is equal to r square. So r square is 1 by 2, right? 1 by 4 plus 1 by 4 is 2 by 4, 1 by 2. So always take r to be positive. So we will have r to be equal to 1 by root 2. Therefore, equation of sphere is x minus 1 by 2 whole square, y minus 1 by 2 whole square plus z square is equal to r square. So r square is 1 by 2. If you want, you can expand this in a minus b whole square formula. You can get that in general form. If you expand this in a minus b whole square formula, a minus b whole square formula, you will get the equation of the sphere in general form. Here it is in central form, no problem. If you expand this in a minus b whole square, you will get that equation. Okay. So find the center, find the center and a radius of the sphere. Find the center and radius of the sphere. X square plus y square plus z square minus 2x plus 4y minus 6z minus 11 is equal to 0. Right? This is a very basic problem. Just to make you more convenient, I'm just doing this problem. So they have given the equation circle in general form. So it is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. Now compare this. So you will have 2u is equal to minus 2, 2v is equal to 4, 2w is equal to minus 6, d is minus 11. So we have u to be minus 1, v to be 2, w to be minus 3. So therefore, center is minus u minus v minus w. So minus u minus v minus w. This is the center. What about radius? So radius is root of u square plus v square plus w square minus d. So root of u square plus v square plus w square minus d. This will be plus 11. So this will be root 23, right? W x square plus y square plus z square minus 2x plus 4y minus 6z minus 11. So 5, 1 plus 4 plus 9, 5, 14. So root 24, right? So this will be 5, 10, 14, root 25, right? Sorry. Yes. root 25. So 5 is the radius. Okay. So we'll move on to third problem. Find the equation of sphere. Is two rounds are clear, right? It's a very simple problem. Find the equation of sphere. Find the equation of sphere which passes through a comma 0 comma 0, 0 comma b comma 0, 0 comma 0 comma 0, 0 comma. So we need to find the equation of sphere that has to pass through these 4 points, right? So again, very simple. Okay. So let the equation of sphere be. So let the equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0, right? Now it passes through these 4 points. So substitute all these points, you will have a set of equations. Only thing is we don't know u, v, w, d. So our aim is to find the values of u, v, w, d. Then we get the equation of sphere. Now it passes through uh, first origin. So it passes through origin means you will have d to be equal to 0, right? Because x is 0, y is 0, z is 0. So 0, 0, 0, 0, 0, 0. So we will have d to be equal to 0. So if d is 0, we can cancel this term. Now it passes through a comma 0 comma 0. So substitute this here. So you will have a square plus 0 plus 0 plus 2ua plus 0 plus 0 is equal to 0. So you will have a square plus 2ua is equal to 0. So we will have 2ua is equal to a square, right? 2ua is equal to minus a square. So you have u to be equal to minus a by 2. I'm just trying to find UVW in terms of ABC because ABC we can get that from the question. So u is minus a by 2. So again it passes through 0 comma b comma 0. So again substitute here. So 0, so you will have b square plus 2vb is equal to 0. So you will have b square is equal to minus 2vb. 1b will get cancelled. So you will have b to be equal to minus b by 2. Now again it passes through 0 comma 0 comma c. So if substitute here, x square 0 square 0 square, c square, u is 0, y x is 0, y is 0, 2wc is equal to 0, c square is equal to minus 2wc. So we have w to be equal to minus c by 2, right? See, very important equation we are doing, right? So from now on, if you want to find equation of, see, what is this? What are these 4 coordinates? It is nothing but the plane intercepts, right? It is nothing but the plane intercepts, right? See, d is 0 only, right? It passes through 0 comma 0 comma 0. So substitute this x, y, z here. So 0 square, 0 square, 0 square. 2 times u into 0, 2v 0 plus 2w 0 plus t. So all these terms are 0. So we have d to be equal to 0. Not confusion. Very simple, right? I'm just putting all these points in this equation. If you substitute x by z to be here, you will get 0, 0, 0. These are all 0. So you will have d to be equal to 0. Okay. So therefore, equation of sphere is given by, so x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. So we have x square plus y square plus z square. So 2u is minus a by 2 minus a by 2x. 2b is minus b by 2 into y plus 2wz. So w is minus c by 2 into z, d is 0. So therefore, x square plus y square plus z square minus ax minus by minus cz is equal to 0. This is the equation of sphere that passing through these points. Actually, what are this? This is nothing but, so what are these intercepts? This is the okay. Let us draw the diagram. A very important equation. So whenever, if you want to find equation of sphere that passes through the intercepts and origin, the equation is x square plus y square plus z square minus ax minus by minus cz plus d is equal to 0. Right? Okay. Okay. See, we are finding a sphere that has to pass through. See, this is our origin and these are intercepts, right? This is our a comma 0 comma 0. This is our 0 comma b comma 0. This is 0 comma 0 comma c. So we are finding a sphere, right? We are finding a sphere that passing through the intercepts and origin, right? So this is 3D, right? So this is 3D. So that sphere is passing through all these 4 points. So whenever if you want to find equation of sphere, just remember x square plus y, that is passing through these 4 points. Very important, right? Very important. That is x square plus y square plus z square minus ax minus by minus cz plus d is equal to 0. We'll move on to fourth problem. To find the equation of sphere. See, this question can also be asked as find the equation of sphere which passes through origin and intercepts length a comma b comma c on xyz axis respectively. Right? Write it down what I am saying. Find the equation of sphere which passes through origin and intercept length is a comma b comma c. Find the equation of sphere which passes through origin and intercept length a comma b comma c on xyz axis respectively. The same question can also be asked like this, or it can also be asked like the plane ABC whose equations is x by a plus y by b plus z by c is equal to sorry, the plane ABC whose equation is x by a plus y by b plus z by c is equal to 1 meets the axis at xyz respectively. Meet the axis at ABC respectively. Find the equation of sphere OABC. Right? Do you want me to write those two questions? This question can also be asked in two other ways. The first way is find the equation of sphere which passes through origin and intercept length ABC on xyz axis respectively. This is one aliter. Other question, same answer only but different question. The plane ABC whose equation is x by a plus y by b plus z by c is equal to 1 meets the axis at ABC respectively. Find the equation of sphere OABC. OABC is the passing through these 4 points, right? Okay. We'll move on to problem number 4. Whenever you are finding the sphere that passing through these three intercepts and origin, this is the procedure, right? It can also be asked like find the equation of sphere passing through origin and making a intercept length ABC in XYZ axis, or find the equation of the sphere formed by the plane x by a plus y by b plus z by c is equal to 1, that passing through OABC. All are same only. We'll move on to fourth problem. So find the equation of sphere. Find the equation of sphere passing through 0 comma 0 comma 0 0 comma 0 comma 1 comma minus 1 minus 1 comma 2 comma 0 1 comma 2 comma 3 comma 2 comma 1 comma 2 comma 3. See, these kinds of problems are very important, right? They will give 4 points. They will ask you to find the equation of sphere. Very simple. Only thing is you need to solve for UVW. We need to solve for UVW. Since it passing through origin, see, in order to find equation of sphere, you need UVWD, right? UVWD, all these four values. If it passing through origin means surely D will be 0. Because if you substitute those points, you will get D to be equal to 0. Right? But here also D will be 0 because it passing through origin. That means if you substitute these 3 points, you will have three equations in UVW. Solve by linear algebra. That is the best way I'll be suggesting. If this is not passing through origin, if it passes through 4 points, not all, that is none of them is origin, means you will have four variables you need to find u, v, w, d. So you will have four unknowns and four equations to solve by Gaussian elimination method. If it passing through origin means you will have three unknowns u, v, w. If there is no, instead of this origin, if you have some other point means you will have u, v, w, d. So you will have four unknowns. So you need to solve by, you will have four unknowns, four equations. Solve by Gaussian method, right? I think you are getting my point. Okay. So let the equation of sphere be. So the equation let the equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. So we don't know UVWD. It passes through it passes through it passes through 0 comma 0 comma 0. So surely d will be 0, right? Because 0 0 0 0 0 0 d will be 0. Now we substitute these points. It passes through it passes through 0 comma 1 comma minus 1. So x will be 0. So we will have 1 square plus 1 square. U will be 0. 2v y is 1. 2w z is minus 1. You just don't put plus d because d is 0, right? I'm just cancelling out. So you will have 0u plus 2v minus 2w. So we will have 1 plus 1 is 2. Bring that to that side. So we will have minus 2. Cancel 2, 2, 2. So you will have the first equation is b minus w is equal to minus 1. Right? R 0u plus b minus w is minus 1. Now again it passes through minus 1 comma 2 comma 0. So 1 plus 4, right? Z square is 0. 2u into minus 1. 2v into y. Y is 2. Z is 0. So we will have minus 2u plus 4v is equal to minus 5, right? And again it passes through 1 comma 2 comma 3. So x square plus y square plus z square 2ux. So 2u into 1 2vy plus 2wz equal to 0. So we will have 2u plus 4v plus 6w is equal to, so, minus 14. That's it, right? So you have three equations and three unknowns. So solve by Gaussian elimination method, right? Solve by Gaussian elimination method. See, I'm not going to introduce Gaussian elimination method. I'm assuming that everyone knows Gaussian elimination method, right? If not, watch my linear algebra Unacademy videos. Okay, these are 12th standard level only. You can either solve by Kramer's rule, but I will always prefer Gaussian elimination method or Gauss elimination method, whatever way you pronounce. Um, so you have three sets of equations, right? So we have, this is non-homogeneous equation. Why non-homogeneous? Because output is non-zero vector, minus 1, minus 5, minus 14. So this is a non-homogeneous equation. Ax is equal to b. Now we need to solve Ax is equal to b. Now solve 1, 2, 3. See, if one of the point is not origin, means if this is some other point, means d will not be 0. In that case, you will have four unknowns, u, v, w, d. Four unknowns, right? Four unknowns you will have and four equations you will have. Again, Gaussian elimination method only. Okay. Now solve 1, 2, and 3. Now solve for 1, 2, and 3. So this is a non-homogeneous equation because b is not equal to 0. So just x is UVW. X is unknown. Here it is UVW. A is the coefficient matrix. So u is 0 here. B 0, 1, minus 1. Right? 0, 1, minus 1. My UV. So minus 2, 4, 0. Minus 2, 4, 0. And here 2, 4, 6. 2, 4, 6. And the unknown is UVW. And what about the output vector P? Minus 1, minus 5, minus 14. So always go for Gaussian elimination method because this will always work. Okay. So for Gaussian elimination method, you need to find the augmented matrix AB. See, I'm just interchanging this row and columns. Okay, first write it 0, 1, minus 1, minus 2, 4, 0, 2, 4, 6, minus 1, minus 5, minus 14. So we need to convert this to row echelon form. So first let us convert interchange R1 and R2. This is equivalent to minus 2, 4, 0, minus 5, 0, 1, minus 2, 4, 6, minus 14. See, what about row echelon form? First row, first non-zero element. Below that, everything has to be 0. First row, first non-zero element. Below that, everything has to be 0. So first row, first non-zero element is minus 2. Below means the corresponding column has to be everything 0. But here 2 we have. So we need to make that 2 0. So we'll R3 is transformed to R3 plus R1 because 2 minus 2 is 0. So minus 2, 4, 0, minus 5. Just keep this as it is. So 2 plus 2 is 0. 2 minus 2 is 0. 4 plus 4 is 8. 6 plus 0 is 6. Minus 14 is minus 19. Right? Now first row, first non-zero, below that everything is 0. Yes. Now go for second row. Second row, first non-zero element. Second row, first non-zero element is 1. Below that everything has to be 0. But here it is not 0. Then only we say it is in echelon form. So we will make use of the operation R3 is transformed to R3 minus 8 times R2. You need to make the 0 with the help of this element only, right? So R3 minus 8 times R2. So you will have, so this is equivalent to minus 2, 4, 0, minus 5, 0, 1, minus 1, minus 1. See, we have to multiply 8 and then subtract. So 0, this will be 0. So 0, 0. So 6 minus 8 into minus 1. It will be 6 plus 8. 6 plus 8 is 14. Minus 19 plus 8. Minus 19 plus 8. It will be minus 11. Right? It will be minus 11. So V minus W is equal to minus 1 minus 2U plus 4V is minus 5. 2U plus 4V plus 6W is equal to minus 2, 4, 6, 9, 14 minus UV, W is minus 5, UVW. Everything is correct, right? So minus 19, 0, 1 minus R3 plus R. That mistake you have made. Let us try to solve this, right? Everything is correct, right? Is there any mistake we have made? So V minus W is minus 1. V is equal to minus 1 minus 2 plus 4B 2VW. We are just transforming this, so minus 2, 4, 0 minus 5, 0. This plus. So now we can see it is in row echelon form, right? So first row, first non-zero element, below that everything is 0. Second row, first non-zero element, below that everything is 0. Third row, first non-zero element is 14. Below there is no element, so therefore it is in row echelon form, right? So just solve this. So you will have minus 2U plus 4V is equal to minus 5. Here we have V minus W is minus 1 and 14 times W is minus 11, right? You just have to revert this to again AX equal to B. This is a new quotient matrix. So minus 2U plus 4V is equal to minus 5. V minus W is minus 1. So from here we have W to be minus 11 by 14. Right? All this has 1, all this has 2, all this has 3. Now from 2, V minus W is minus 1. So V plus 11 by 14 is minus 1. So V is minus 1 minus 11 by 14. So it is minus 25 by 14. You're not getting the answer. I don't know whether it is typing the book answer is wrong or our answer is wrong. You are getting here b to be equal to minus 9 by 7. Passes through 0, 0, 0, 0, 1, minus 1, minus 1, 2, 0, 1, 2, 3. Let us see whether it satisfies this equation or not. So u is minus 14 minus 11. Fourteen pies are. See, so u is 10 by 7. So we are getting UVW as this. Let us see whether it satisfies this equation or not. First equation is V minus W should be minus 1. So V is minus 25 by 14 minus W minus WD plus 11 by 14 minus 25 plus 11. Yes, correct only. Right, minus 25 plus 11 is minus 14. Similarly, we should have minus 2U plus 4V to be minus 5. So minus 2 times U. U is minus 10 by 7 plus 4 times B. B is minus 25 by 14. So this is 20 minus, no, this is 20 by 7 minus 100 by 14. So into 2 into 2. So you will have 40 minus 100. So it is minus 60 by 14. Yes, minus 5. It's correct only. Book answer is wrong. So this is our UVW. Right? This is our UVW. Now substitute back, you will get the required answer. Right? So therefore, the equation of sphere is given by x square plus y square plus 2ux plus 2vy plus 2wz plus d equal to 0. So what is u? U is minus 10 by 7 square plus y square. U is minus 10 by 7 2v. So v is minus 25 by 14 plus 2 times w. W is minus 11 by 14. P is 0. Right? So this is the required equation of sphere. If you want, you can say, simplify it. This is the required equation of sphere. Right? Yes, in the book, the problem is the solutions is wrong. So, just try this problem, right? I think this is correct because this UVW satisfies these equations. That means it has to be correct, right? And again, u plus 2v plus 6w will give you minus 14. You can check this out also. Minus 2 times u is minus 10 by 7. So minus 10 by 7 plus 4 times v is minus 25 by 14. So you will get minus 100 by 14, 20 by 7 into 2 into 2, 40 minus 100 is minus 60. 14 5 are, yes, correct only. This is the required equation of sphere passing through these 4 points. Is it clear, right? Can you move on to the next problem? Okay. See, very simple. You just substitute these equations here. You will have a set of simultaneous equations. Solve the equations using linear algebra. That's it. We'll move on to problem number 5. Find the equation of sphere. Find the equation of sphere passing through passing through 1 comma minus 3 comma 4, 1 comma minus 5 comma 2, 1 comma minus 3 comma 0, and whose center lies on the plane x plus y plus z equal to 0. So again you can see here you will have four unknowns here, right? Because there is no origin here. So you will have u minus, the equation first is wrong. V minus v minus w is minus 1 only, right? 1 plus 1 is 2. Bringing this minus 2 that side. I'm just cancelling 2 alone. So you will have v minus w is correct only. It satisfies, right? Okay. So find the equation of sphere that passing through these 3 points and whose center lies in this plane, right? Solution. So let the equation of sphere be, let equation be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Now you substitute these 3 points. So you will have a equation in UVWD. So you will have 4 unknowns now. So it passes through. So it passes through 1 comma minus 3 comma 4. So x square plus y square plus z square 2ux 2vy plus 2wz plus d equal to 0. So you will have 2u minus 6v plus 8w plus d equal to 9 plus 1 is 10, 10 plus 16 is 26. So you will have minus 26, right? 2u minus 6v plus 8w plus d is equal to minus 26. Now again it passes through. See, I'm not going to do this problem, right? Just linear algebra problem. We are just solving. Uh, we are just solving a set of simultaneous equations, right? Just go through my linear algebra video if you haven't watched. You don't know how to solve. These are 12th standard level only. So just form augmented matrix. So we'll have 4 unknowns now. Reduce to row echelon form and find the unknowns by backward substitution method. So it passes through 1 comma minus 5 comma 2. So we'll have one more equation. Then I'm going to do this directly. 2u into x. So we will have 2u, 2v into y. So we will have minus 10v, 2w into z. So z is 2. So we'll have 4w plus d is equal to x square y square z square. So 1 plus 25 is 26. 26 plus 2 is 30. Take that side. So we'll have minus 30. Now again it passes through. It passes through 1 comma minus 3 comma 0. So I'm going to do this directly. So 2u into x is 1. 2v into y. So y is minus 3. So we'll have minus 6v. W is 0. So we will have 0w plus d x square y square z square. So 1 plus 9 is 10. It will be minus 10. This is equation number 1. Equation number 2. Equation number 3. Now it is given that center lies in this plane. Now what is center? Now center is minus u minus v minus w lies on that plane x plus y plus z equal to 0. That means this coordinate will satisfy this equation. So you will have minus u minus v minus w plus 0 d equal to 0. Right? Now solve for 1, 2, 3, 4. I'm not going to do this. Now solve for 1, 2, 3, 4 by Gaussian elimination method. Gaussian elimination method. You will get the unknown values of u, v, w and d. So you will have u to be equal to minus 1, v to be equal to 3, w to be equal to minus 2, d to be equal to 10. Right? You can do this very easily. Just you will have four unknowns here, u, v, w, d, solved by Gaussian elimination method. Right? Very simple problem, but it will take time. That is the only concern for this problem. Okay, so now we'll move on to problem number 6. Problem number 6. Okay. Just a minute. Okay. Move on to sixth problem. A sphere of radius k. A sphere of radius k passes through the origin. Passes through the origin. Passes through the origin and meets the axis. And meets the axis in a comma b comma c. Prove that the centroid of the triangle ABC of the triangle ABC lies on here 9 times x square plus y square plus z square is equal to 4k square. Very important problem and again very easy problem. So you just recall centroid of triangle formula, centroid of tetrahedron formula. then this will be very easy to follow. Okay, so we have a sphere of radius k and passes through origin and meets the axis in A, B, C respectively. So let us assume the center to be A, B, C. Prove the center of triangle ABC is A, B. Okay, see, very simple. We have a sphere of radius k. So we have a sphere of radius k and it is passing through origin and meets the axis at A, B, C. Right, so it meets the axis at A, B, C, and this also passing through origin, right? So let us keep a sphere here. Sphere is passing through origin and meets the axis at ABC. Okay. Now prove that the centroid of the triangle ABC lies on this sphere. Okay. So we have a centroid, right? So we already know what is centroid. What is centroid of ABC? So it is nothing but the intersection point of the medians or altitude. We have a triangle. We already done this problem in planes also. So we have, let us draw a medians. This is one median, this other median, this other median. This is the centroid. Now we need to show this centroid lies in the sphere. That is, this centroid lies in the sphere, right? Okay. So we'll start this problem. Very simple problem. So it is given that sphere. It is given that radius is k and passing through origin and meets the axis in ABC respectively. That means what? Equation of sphere. Equation of sphere passing through origin and meets the axis. Equation of sphere passing through 0, 0, 0, A, 0, 0, 0, B, 0, 0, 0, C. We already found this equation, right? What is this equation? Equation of sphere passing through origin and intercepts. So it is x square plus y square minus ax minus by x square plus y square plus z square minus ax minus by minus cz is equal to 0. This is the equation of sphere that passing through origin ABC. Okay, fourth problem. Sorry, third problem. Equation of sphere passing through these 4 points is x square plus y square plus z square minus ax minus by minus cz. I'm writing this directly. So refer problem number 3. This is the equation of sphere. Now prove that the centroid of triangle ABC. Now what is centroid of this? This point is A, 0, 0. This point is 0, B, 0. This point is 0, 0, C. Now what is centroid? Centroid, centroid of the triangle ABC is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. So a plus 0 by 3. So a by 3, b by 3, c by 3. This is the centroid of ABC, right? Okay. Now we need to show that the centroid of the triangle ABC lies in this sphere. The centroid lies in this sphere, right? Okay. Now we need to show the centroid lies in this sphere, right? Okay. Now it is given that this has a radius k, right? This has it has a radius k, right? Now what is radius formula? So radius is root of u square plus b square plus w square minus t. So that means radius is k, root of. Now what is u? What is u? What is v? What is w? So you have 2u is equal to minus a. Compare with general form, 2v is equal to minus b, 2w is equal to minus c. So you have u to be minus a by 2, b is minus b by 2, w is minus c by 2. So u square a square by 4 plus b square by 4 plus c square by 4, and d is 0, right? D is 0. So that means if I square this, so you will have k square to be equal to 1 by 4 a square plus b square plus c square, right? Square this, so k square root will get vanished. So let us take that side. So we will have 4k square is equal to a square plus b square plus c square. This is they have given that it is radius is k. Now prove that centroid of triangle ABC lies in the sphere. Yes or yes only, right? Because what is centroid? Now centroid. What is centroid? We already found, right? It is a by 3. Centroid is x comma y comma z, which is a by 3, b by 3, c by 3. So you will have x is equal to a by 3, y is equal to b by 3, z is equal to c by 3. So we have a to be 3x, b to be 3y, c to be 3z. Substitute back here. So we will have 4k square is equal to a square plus b square plus c square. So we will have 4k square is equal to 9 times. This is what we need to prove, right? Very simple problem. So a sphere of radius k passing through origin and these points. So that means that equation is this, and the radius is, we know the formula, right? So radius is given to be k. Now this is the radius sphere radius. Now centroid is, we know, substitute back here. You will get that centroid lies on the sphere. Okay. Number 7. A sphere of radius 2k passes through origin and meets the axis in ABC respectively. Find the locus of centroid. Find the locus of centroid of the tetrahedron UABC. Very easy problem. You can do this. See, in the previous problem, we are finding locus of centroid of triangle ABC. Right? Here we are finding the locus of centroid of tetrahedron OBC. What is the formula? x1 plus x2 plus x3 plus x4 divided by 4, y1 plus y2 plus y3 plus y4 divided by 4, z1 plus z2 plus z3 plus z4. Sorry, x1 plus x2 plus x3 divided by 4. You know formula for centroid of tetrahedron, right? So we will have a by 4, b by 4, c by 4 as your tetrahedron. Already we have done this problem, right? Okay, but it is in terms of sphere here. So same problem only. So what is the equation of sphere passing through origin and meets the axis ABC? The required equation of sphere is, writing directly, the required equation of, sorry, yes, the required equation of sphere passing through origin, intercepts. right? What is that equation? It is x square plus y square plus z square minus ax minus by minus cz equal to 0. This is the equation of sphere passing through origin and intercepts. Now it is given that radius is 2k. So we have 2u to be equal to minus a, 2v is equal to minus b, 2w is minus c. So we have u is minus a by 2, b is minus b by 2, w is minus c by 2. It is given that radius is 2k, right? So we have what is radius? The previous problem radius is k. Radius is root of u square plus v square plus w square minus d. So here d is 0. So radius is 2k. So root of u square plus v square plus square by 4. So square it up. You will have 4k square. You will have 4k square is equal to 1 by 4 a square plus b square plus c square. So this will be 16k square is equal to a square plus b square plus c square. Now what is centroid of tetrahedron? Centroid of tetrahedron OABC, right? Let that be x comma y comma z. So it is 0 plus 0 plus a, x1 plus x2 plus x3 plus x4, x1 plus x2 plus x3 plus x4 divided by 4. So we will have 0 plus a plus 0 plus 0 divided by 4, y1 plus y2 plus y3 plus y4 divided by 4, z1 plus z2 plus z3 plus z4 divided by 4. So the centroid is a by 4, b by 4, c by 4. I'm not writing the formula, right? We have already given this in planes itself. Centroid of OABC is x1 plus x2 plus x3 plus x4 by 4, y1 plus y2 plus y3 plus y4 by 4, z1 plus z2 plus z3 plus z4 divided by 4. So cross multiply this, so we will have a to be 4x, b to be 4y, c to be 4z. Substitute back here. So the locus is given by 16x square is equal to 16 x square plus y square plus z square, right? A square, b square, c square. So 16x square, 16y square, 16z square. So cancel this 16. So x square plus y square plus z square is equal to k square. This is the locus. Right? What is k? K is the 2k is the radius, half of the radius is k. Is it clear? It's a very simple problem. Previous problem, centroid of triangle ABC is x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, z1 plus z2 plus z3 divided by 3. That is centroid of triangle ABC. Centroid of tetrahedron with 4 vertices is x1 plus x2 plus x3 plus x4 divided by 4, y1 plus y2 plus y3 plus y4 divided by 4, z1 plus z2 plus z3 plus z4 divided by 4, right? Okay, move on to 7th problem, 8th problem. Find the equation of sphere. which passes through, this will not be very good problem. And the equation of sphere which passes through, which passes through 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0 comma 1, as its radius and as its radius as small as possible, as small as possible. Very important problem, very interesting problem. So we need to find an equation of sphere that passes through these 3 points, and the radius is as small as possible. So we need to find a smallest sphere, smallest radius sphere that passes through these 3 points, right? Okay. So first, so let the equation be, let the equation of sphere be, let the equation of sphere be. I'm going to introduce calculus here because we need to minimize the radius. So that means we need to find maximum. You need to bring maximum minima concept here because we need to minimize the radius, right? Okay. So let the equation of sphere be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus p equal to 0. Now it passes through these 3 points, right? It passes. This is the required equation, but we don't know UVWD. It passes through. So it passes through 1 comma 0 comma 0. So that means we will have 1 plus 0 0, 2u plus d 0. So we have 2u is equal to minus d minus 1. So we have u to be equal to minus 1 by 2 d plus 1. And similarly, it passes through 0 comma 1 comma 0. So 1 plus 2v plus d equal to 0. So we have 2v is equal to minus 1 minus v. So again v is minus 1 by 2 d plus 1. Now again it passes through. It passes through 0 comma 0 comma 1. So 1 plus 2w plus d equal to 0. So in this case, your UVW turns out to be same, right? So substitute back here. Now we need to minimize the radius, right? See, if I find d, the problem is over, right? Because if I find d alone, I can substitute d here, d here, d here. So UVW will be in terms of number. But the concern here is radius has to be as small as possible. So what is radius? So radius is root of u square plus v square plus w square minus d. This has to be as small as possible, right? Let us square this. So you will have r square is equal to u square plus v square plus w square minus d. Let us keep this as capital R, right? If R is minimum, R square will be minimum, right? Let us keep this as capital R. We need to minimize R. That is same as minimizing this capital R, right? Okay. Now what is u square, v square, w square? So it is 1 by 4, 1 by 4, 1 by 4. So you will have 3 by 4. See, I'm just squaring and adding. This is 1 by 4, 1 by 4, 1 by 4. So d plus 1 whole square will be common. So 1 by 4, 1 by 4, 1 by 4 is 3 by 4. So 3 by 4 d plus 1 whole square minus d. So u square, v square, w square. So u square is 1 by 4 d plus 1 whole square. 1 by 4 d plus 1 whole square. 1 by 4 d plus 1 whole square. So if I add it up, 1 by 4, 1 by 4, 1 by 4 will be 3 by 4. D plus 1 whole square I'm taking outside. Now we need to minimize this, right? So we need to minimize this, right? That is minimizing R. So that means dr by we need to differentiate with respect to d. So we should have dr by d you will differentiate with respect to d, right? So we will find minimum value of d, right? So that means first we will find critical point. So dr by dd, right? dr by dd. See, this d is differentiation and this d is in this d, right? Don't confuse with that. Now if I differentiate with respect to d, so we will have 3 by 4, 2 into d plus 1 minus 1. So for critical point, this has to be 0, right? You know how to find maximum minima, right? First we find critical points. That is, you are finding the values where the slope is 0. So 2 times d plus 1 minus 1. So this will be 2 ones are 2 twos are. So 3 by 2 d plus 1 equal to 1. So d plus 1 equal to 2 by 3. So d is equal to 2 by 3 minus 1. So d is minus 1 by 3. So we have only one critical point, right? We have only one critical point. Now if now you find d square r by dd square, that is I'm finding second d square y by I'm finding second derivative, right? That is r double dash. What is r double dash? Now differentiate this once again. If you differentiate this once again, what you will have? This is dr by dd, right? I'm differentiating once again. So that means derivative of d is 1. So you will have 6 by 4 only, right? Which is always greater than 0. That means these second derivative is greater than 0. So that means it attains minimum value. This does not depend upon d. So it is always greater than 0 only, right? If it is some d means you will substitute here, but it is always greater than 0 only. So that means at d is equal to minus 1 by 3, it attains minimum. So that means d will take the value minus 1 by 3. That's it. Is it clear? How to find d? See, if I find d means the problem is over. Everything will be in number. But we need to make use of this condition that radius is as small as possible. So we know radius formula. From this, I'm trying to find the minimum value of capital R, right? Because radius is this, right? So we'll get at d is equal to minus 1 by 3, it will be minimum. So all are same only, right? UVW, all are equal to minus 1 by 2 d plus 1. So this will be minus 1 by 2. So d is minus 1 by 3 plus 1. So minus 1 by 2, 3 minus 1 is 2 by 3. So you will get UVW to be equal to minus 1 by 3 and D is also minus 1 by 3, right? So therefore, the equation is x square plus y square plus z square plus 2ux plus 2vy 2wz plus d is 0. So everything is minus 1 by 3. X square, y square, z square minus 2 by 3x minus 2 by 3y minus 2 by 3z minus 1 by 3 is equal to 0. This is the required equation of sphere. Is it clear? Very interesting problem, right? So we need to find an equation of sphere that passing through these 3 points and as well as radius has to be minimum. Radius has to be minimum. Okay. We'll move on to problem number 9. I think we can stop here. I have one more class at 8 o'clock. Okay, so I'll stop here. The next class, we will continue from 9th problem. So sphere is very easy, right? It does not involve many concepts. Only thing is it involves radius, spheres, radius and centers, right? So we'll see in the next class, right? We'll continue in the next class. For next class, we will start with ninth problem. So I hope there will be no doubt in this class. So in this class, what you have seen is we have just introduced equation of sphere in central form and in general form. And then we have solved 8 problems based on that. In the next class, we'll start with ninth problem, right? So thank you. All the best.